Hi guys, so now we will be learning about how to train with multiple data points and data loader. So the objective of this lesson is to understand how PyTorch training scales from a single data points to multiple samples using batches and data loader without changing the code training logics. So what is datasets? Datasets stores input and output pairs. What is batch? A small group of samples processed together, and data loaders feed data in batches during training. Why data loader is needed? Real-world datasets are large and cannot be processed all at once. Data loader help us by splitting data into batches. So we make batch like there is a batch size. Let us take a batch size of 8 and we have a total 32 data point. So if a batch size is of 8, so 4 batches will be made. So we split the data into batches to process them properly, because in real scenarios there are not 32 data point. There are like uh, thousands and like million number of data is also available, so we have to split it into batches, shuffling data so that the data inside the batch should be shuffled and iterating efficiently over samples. Now, example dataset, we consider a simple linear relationship y equals to 2x. So we start by we can import tensor datasets and data loader like this. Now later like our x data is a tensor 1 2 3 4 and our y is 2 4 6 8. Okay. Now we will load our dataset like this, and sorry, we will store the input output pair like this, and then we will load our data set with a batch size of 2. So here there is 4 data, so there will be 2 batches of 2 2 2. So yeah, and shuffling is also enabled. So this data will be loaded through data loader, as data loader feed data in batches during training. Now the model definitions. So we will import torch.nn. Now we will define our model, linear model, and model will init self, superint, same as like this. These two are learnable parameters, so we write it, and then we define our forward. So this will be like this as model equation. Sorry, y equals to wx plus b. So we are writing it as like this. Now. Yeah. Now, uh, this is for MSc loss, as we have studied in our previous lecture. This is for optimization with learning rate 0.1. Now this is the actual training loop with batches. So what happened here? There is a term called epoch. So how many time we actually want our model to see whole data. The epoch tells us how many times we actually want our model to see whole data. So here we want it to see 10 times. Now we will load like for X batch comma Y batch in a loader. First batch, we take a first batch and try to predict, calculate loss, then gradient, then update the weight, and then we made our gradient value equals to 0 so that it cannot get accumulated. We do it for all batches in one epoch, then again in second epoch same thing happened, third epoch same thing happened. So now epoch versus iteration. What is epoch? Epoch is a one full pass over the data set, and iteration is one parameter update. It means, so if anyone asks you what is how iteration per epoch, what is the value of iteration per epoch? So iteration is one parameter update. So after every for every batch there is a parameter update. So if in like if one epoch you are seeing whole data set, and your data set like your data set size is 32 and your batch size is, let's say your batch size is 4, it means that how many batches you have? 8 batches. So it means that 8 times parameter update will happen in one epoch. Then that's why here it is data set size upon batch size. Okay. Now if anyone asks you like how many times iteration will happen in 10 epochs, so you will firstly find how many times iteration will happen in one epoch by dataset size upon batch size, then you will multiply it with epoch. The effect of batch size: smaller batch size, more updates, noisier gradient; larger batch size, fewer updates, more stable gradients. So we have to put a like a batch size like we have to keep a proper batch size. Now broadcasting. PyTorch automatically applies operation element-wise when tensor ships are compatible. This allows scalar parameters to work with batch inputs. So this is like the tensor size should be correct. Like when you will be doing coding with like when you will be tackling real world problems, you'll find sometime errors like tensor size not matching this. So this actually happen when we don't give proper tensor size dimensions, proper dimensions for like multiplication. Like in multiplication, if one matrix is m cross and another should be n cross something, and if that matrix is not of that dimension, it will be giving that tensor size mismatch and something like that, as it throw error like that. Now key takeaways: training logic does not changes with batches as you have seen it. Data loaders only provide data, it does not train the model. Batch size affects the number of updates, not the model structure, as you have seen this all takeaways in our lecture. Now let's examine feature vectors and nn.Linear. Now, the objective of this lesson is to extend linear regression from a single scalar input to a multiple input feature using vectors and dot linear and a linear layer. Now, before this lesson, what we were assuming like we have only one feature, but in real world scenarios, we don't have only one features. We have many features, and basis of all features, we predict our target. So this lesson will be dealing with that. So now, from scalar to vector input, earlier the model was y equals to wx plus b. Here x was a scalar. In real world problem, x will be a vectors or have a multiple features x1 comma x2 comma x3. So our model will be something like this. Now the tensor shape. Assume batch size equals to b. Number of features, assume it is number of feature 1, 2, 3. So here it is 3. So what will be the size of input tensor? As your batch size is b, it means that you can take b samples at a time, and let's say b equals to 2, and you have total data, your data set have 10 samples. So you will be taking 2 samples at a time, and each samples have 3 features, so its dimension will be 2 comma 2 into 3 or 2 comma 3. Same way here we are writing b comma 3. Now what will be the weight vector? So you have 3 features, so there will be 3 weights for means there will be weight for each feature, so there will be 3 weights, so it will be 3 comma 1. Bias shape will be 1 because there is only one bias plus b you are doing. Yeah. Now output will be for a particular input tensor, output will be like how many batches you have taken. If you have taken b batches, so there will be b cross 1, because output is here output, you are predicting only one label, not like, so that's why here it is one, like one column only you are predicting, so here it is one. Now why nn.Linear exist? Manually managing weight vectors and bias is error-prone. PyTorch provides nn.Linear, where we pass in feature and out features as argument. For example, nn.Linear. Here we are passing in features. Like we have 3 features, features column. So here 3 and only one output feature column. So 1. This internally creates the weight matrix as 1 comma 3, because we have 3 features, so there will be 3 weights, and bias vector of shape 1. The underlying math remains the same. Now we'll see one complete code. So this way we import torch and torch.nn. Now input data, we take the batch size of 2 and we have a feature 3. Now here you can see we have only two data sets. So batch size 2, this means that only one time this loop will be running, because we have only two instances in our data, and here 3 features, we have 3 features. Okay, this is your output. Now you don't have to make a class for models. Directly you can write nn.Linear. Now here it is input feature and this is output. So in feature you have three features, and out there is one. You can see one, this one column, and here there is three columns. Now criterion, like nn.MSC loss, because we are using MSC as our loss. This is for optimization. Now loop. So we are running 100 times. This y predicted will store your predicted model value for particular x, and this is criterion which is calculating a loss, then gradient, then update, then that grad value is becoming 0 due to this line. Now, after every 20 steps, we will check like what is the loss, like, so that we can check after 20 steps, is there any significant loss decrease happening or not. If the model is defined as 3, 2, what does it mean? We have 3 input feature and 2 output feature. So the output step will be b, 2, yeah, and the target tensor must also be b, 2. Yeah, it means that our target is now we have b instances, and for output there is not only one column, there is 2 output columns. Now prediction and target tensor must have the same shape for loss computation, otherwise it will throw an error. Now interview takeaways: in feature equals to number of input feature, out feature is equal to output per samples, batch size does not affect nn.Linear, and shape mismatch between prediction and target causes runtime errors. Okay. Now we will know, we will learn about custom dataset and data loaders. Okay, the objective of this lesson is to understand how PyTorch handles real-world data using custom dataset, and how data loader interacts with it during training. Why custom dataset is required? Tensor datasets works only when data is already available as tensors. In real application, data may come from CSV files, images, text databases. To handle such cases, PyTorch allows you to define a custom dataset. Now, a custom PyTorch dataset and must implement. First, we have two things: length, which returns the number of samples in your data, and .get item index returns but one sample, which is like index value. When you pass that index value, it returns that whole instance of or whole sample at that index. Now, understanding self. Why we are writing self? Self refers to the current object, instance of that dataset. Current instance. It is used to store and access data belonging to the specific dataset object. Okay. Now, custom dataset implementation, we will see the full implementation. So this way we we import torch and utils.data import dataset. Now we will create a custom dataset here. Create simple dataset. We will define in self x data, y data, self x.data, x.data, length. It will give the length of your dataset, like how many samples are there, and this will return the particular x data and y data value at that index. Now, how data loader uses the dataset? When data loader is created this way, from data loader dataset batch size to shuffle true. Internally what happens? It calls length to know the dataset size, get item index to fetch that samples, and groups return samples into batches. As you have batch size of 2, so it will return 2 samples at a time. Now iteration over data loader for x batch comma y batch in a loader, batch of input and batch of target. Now key takeaways: dataset defines how a single data sample is accessed. What dataset tell you? How a single data sample is accessed. So dataset, yeah, wait a minute. Here this dataset, this tells you how a single data sample is accessed. While data loader handles batching and shuffling, self-stored data inside the dataset object and get item must return input and target together. So this is through index. Now interview takeaways: data loader does not store data. Data set does. Yeah, data loader is not used to store data. It does not store data. It's only handle batching and shuffling. Now, custom dataset is required for real-world data. Understanding self is essential for PyTorch pipelines. Now lesson 9, into in PyTorch pipeline, we will see one into in PyTorch pipeline. The objective of this lesson is to understand a complete PyTorch training pipeline starting from raw data to a trained object. Okay. So here we have a real world PyTorch workflow. Load raw data, wrap data in custom data set, use data loader for batching, define a model, training in standard training loop. So here this is our y equals to x1 plus 2x2. This is a simple, we consider simple data set with two features. And now here we will be loading this all. Now this is our data and this is its input by putting into this equation. Now how we will make our custom data set as we have studied earlier, cell.x, cell.y, length, index, through get item. Now you'll load your data set here, CSV data set x comma y, how you have done here, same way. Yeah. So same way like how data set, I guess that line is not here. It should be data set equals to simple data set. We should call that same like here. We have defined first is CSV data set and then we have called CSV data set x comma y to load that value inside it. Now data set, now data loader is called for batching and stuff like it is inside loader batches and x batch and comma y batch. Now we will create our model, define our model, and then here the loss definition and optimization. Now we are running it for 100 epochs. We will for loop for x batch comma y batch in loaders for particular for each batches. In one epoch, like in one epoch, we will see all the data set, but in batches. So how many iteration will be there? Number of iteration will equal to data set size upon batch size. Y predict will be calculated, loss calculation, then gradient, then update, then it will make the then gradient value will be 0 because it will accumulate if we not make it 0. After every 20 box we will check our loss to check if there is any significant decrease or not. Now dataset defines how a single sample is accessed. These are very key, very important lines which usually interviewer asks in interview. So have focus on this part. Dataset defines how a single sample is accessed, while data loaders handles batching and shuffling. Model architecture depends only on feature dimension, while training loop logic remains the same for all problems. Custom dataset is required for real-world problems, and data loader performs batching, not dataset. Data loaders perform batching, not dataset. nn.Linear is defined, and nn.Linear in feature out feature depends on feature count. In understanding is more important than API. Now we will be doing this part in next lecture. Yeah, till then, bye bye. If you like this lecture, you can subscribe my channel. I'm in future I will be bringing more content related to AI. We will be doing paper readings. Yeah, so you can subscribe my channel. Thank you.